All right, for the home link, it looks just like our book, and it says that these two pan balances are in perfect balance. So the pan balance on the left is in perfect balance, and the pan balance on the right is in perfect balance. That means both sides are equal. So one hexagon is equal to or equivalent to two half of a hexagons or a trapezoid. Okay, one of our halves equals three triangles because those are balanced. So if I have 2 equal 1 full hexagon, 1 full hexagon is going to be double those triangles. So 1 full hexagon is going to equal 6 triangles. So I'm just going to leave that there to help us with the next problems. All right, letter A says, use the relationships in the pan balance shown above to determine which of the pan balances below are balanced. Circle the ones that are balanced. So if I look at the one on the left, here I have 2 hexagons and 2 trapezoids and a hexagon. Well, we know that these are both equal to one another, and then this hexagon equals the same as 2 hexagons, because if I look over here, 1 hexagon equals 2 trapezoids or halves. So this one is balanced or equal. So go ahead and circle that one. Now if I look at the one on the right, here we have 2 halves or 2 trapezoids. Would that be balanced with 2 hexagons and a half? No, that's not going to be balanced because 2 of these would only equal 1 hexagon. So we will not circle that pan balance. So do not circle that pan balance. All right, if I look at the one on the bottom down here, we have 3 triangles and a hexagon is equal to 2 triangles and a half of a hexagon or a trapezoid. Would those be balanced? And when it's asking if it's going to be balanced, you're thinking like a teeter-totter. If one side would weigh more, that would not be balanced, okay? If it was the exact same weight, it's going to be balanced. So we're circling the ones that are balanced. So looking at this one, we know one of these hexagons should equal 2 of those halves, or it could also equal 1 half and 3 triangles. So this left side is going to weigh much more than the right side. So we are not going to circle this pan balance. Now looking at our last one. All right, so we know that 1 hexagon equals 2 halves or 2 trapezoids, which is correct. And 1 half equals 3 triangles, So this would be balanced or equal. So we are going to circle this one. All right, for letter B, now it says for any pan balance above that you did not circle, add or cross out objects to balance the pans. Okay, so we're looking at these two now because we did not circle any. So here I have 2 hexagons and a half of a hexagon. This we know equals the same as 1 hexagon. So I could add another hexagon to this side. I'm going to do my best to draw it on here. Okay, and now I would have a total of 2 hexagons, and I need 1 more half of a hexagon, and that would make both of those balanced. For the one on the bottom here, to make those balanced, remember it says we can add or cross out. So I'm going to make the one on the right, and yours could look different than mine, but I'm going to make the one on the right equal to 1 total hexagon. So I'm going to add another triangle because I know that 3 triangles equals a half of a hexagon. And then another, if we take 1 half plus a half, I get 1 full hexagon. Now looking at the right side, if I want this side on the right to equal 1 hexagon, I'm just going to cross out all my triangles. So I'm going to cross out the 3 triangles on the left and add a triangle on the right to make those balanced. Let's move on to number 2. All right, it says find the value of the missing number that will balance each set of pans below. Find the number that is missing from both sides of the pan balance. So you're going to have the same number missing from both sides of the pan balance. So we're going to just plug and chug or guess and check. So let's try if I put 2 in on both sides to see if that would be correct. So here, and I chose 2 because I know 15 times 2 is 30, and I was thinking it might get close. So 15 times 2 would be 30 on the left. And then order of operations, I have 10 plus 30. So the right side would be heavier because that equals 40 on the right. So that's not going to work. Let's try the number 3. So on the left side, we have 15 times 3. 15 times 3 is 45. And then on the right side, we have 5 times 3, which is 15, plus 30, which would equal 45. So since we got the same number on both sides, those would be equivalent. So the number that we need to plug in there is the number 3. So one box is going to equal 3. For letter B, it's a square divided by 6 is balanced or equal to this right side of a square minus 20. So let's think of factors of 6 and try those. So let's try 36. 36 divided by 6 is going to equal 6. 36 minus 20 equals 16. So that does not work. Let's try 30. Oops. So 30 divided by 6 is 5, and 30 minus 20 is 10. That doesn't work. Let's try 24. 24 divided by 6 is 4, and 24 divided by 20 is 4. So my pan balance is balanced or even when I plug 4 in for those squares. So you should have a when you plug 24 in for those squares is what I had up there. Now for number 3, you get to make up your own missing number pan balances. So I'll do letter A for you as an example, and then you can do letter B on your own. So for letter A, let's say I do 3 times a square equals the same as, remember my square has to be equal. So I'm going to have my square equal 4. So this side's going to equal 12. So now I need to make this side. So let's do 8 plus a square. So in both of those sides, if I plug 4 in for that square, I'm going to get 12 because 3 times 4 is 12 and 8 plus 4 is 12. So 4 works in both of those spots. So now you make up your own on letter B. And then for the practice problems, you are multiplying those decimals. Remember when you multiply decimals, you do not line up your decimal. You multiply like regular and then add the decimal on when you're done. So for example, if I did 7 times 3, you get 21, carry the 2. 7 times 4 is 28, plus 2 is 30. So now I'm going to move my decimal over one spot because there is one number on the side on the right of the decimal in that problem. Good luck. Let me know if you have any other questions.